All right. Hey, I'm Karl Rittger, and I'm at the National Snow and Ice Data Center and the Institute of Arctic and Alpine Research at the University of Colorado Boulder. What you see here is the red outline is the gray area, sort of the interquartile range or the middle 50%, along with the driest and wettest years at the top and the bottom, and the median year in the middle. With the blue line here and this point at the very end showing this year's conditions. And I should say that these conditions for the wettest and driest are chosen from the years with the wettest and driest across the Western US, not specific for this basin. So we could have a slightly lower or higher year on those, but they're pretty good proxies generally. The snow-covered area summarized over 24 hours, and then the percentage of mean snow water equivalent. And I usually use that bottom one, the percentage of mean. So I'll click that on. Now you can see this color bar has two colors on it, one for the snow cover, which is the underlying map, and one for SWE, which is on the top there. And what you see here is that on the western portion of the Upper Colorado into Utah there, we have very high values, and this color bar only goes up to 150%. So we're sort of saturating our color bar there. The other things we can look at, and I'm going to use this to sort of add a bunch of data to the map here. So you can view a whole bunch of variables. Snow covered days is basically duration of snow cover. Snow radiative forcing tells us the impact of dust and snow on the snowpack. It melts faster when there's more, dust and carbon. When there's more dust and carbon on the snowpack, it melts faster. And then snow albedo is just that brightness of the snow. So now I've sort of set those. So the top graph here was the snow cover. And then we have snow cover duration or snow cover days here. So you can see that, we're doing well above the 75th percentile. Again, this is a summary graph showing, compared to the previous 22 years from the satellite record. Colorado gets a lot of dust in the San Juans. So we have the radiative forcing map here. You can see that right now, looking compared to the averages, we're sort of we've got the cleanest snowpack or the least dust impact from, on the snow energy balance. And if you look at the snow albedo as well, you sort of see that same thing with high albedo values, meaning it's reflecting a lot of the sun's solar radiation. So yeah, that's kind of the set of data that we have available on here. We bring together the satellite-derived maps of snow cover days, radiative forcing, and albedo, along with the SWE point measurements from the SNOWTEL stations.